My name is Nir. I'd like to thank you for coming for this session. Today I'm going to demonstrate the entire deep learning flow using a tool that we developed at Intel that allows you to easily and fast use deep learning with your own existing hardware. No need to purchase any special hardware accelerators or software. This is all free. And we all hear about deep learning. Deep learning is most definitely one of the most innovative areas in data science today and in machine learning. But before we start, I would like to ask, how many of you have heard about deep learning? Please raise your hand. Just heard about deep learning? How many of you have actually practiced deep learning? So there is a gap between the people who know about deep learning and heard about it and people who actually practiced it. And that's exactly a gap that we're trying to bridge here with this tool. And today, I hope that by the end of the demo, most of you will be able to download the tool and just do the entire flow of deep learning by yourself with your own data or some example data. So Intel is definitely known for its hardware, very good hardware products, but we also use data scientists a lot at Intel, both internally and externally. Internally, we use machine learning to improve our design processes, design and manufacturing. We shorten our time to tests. We also use machine learning in sales and marketing in order to recommend Intel sales team how to improve their sales. We also have some external solutions. We have a large project for healthcare that uses machine learning and big data with the Michael J. Fox Foundation for the Parkinson disease. And we also have a project on clinical trials on Huntington disease. Intel has some IoT solutions that has machine learning embedded in them. And the demo that I will share today is based on the work that is being done in the perceptual computing, which uses deep learning for image processing. So deep learning is definitely the future, but it's already here and now, and it is solving real-life problems. Deep learning excels especially at solving cognitive tasks, such as visual understanding, identifying objects within images and analyzing what they are, analyzing text and documents, classifying documents, translation, and also in audio and speech processing. So a lot of the speech recognition is done based on deep learning. So imagine, for example, the autonomous car industry. You walk into a car, you talk to the car, you tell the car where you want to go. The car analyzes your text. Your voice analyzes the text itself and is able to look at the environment and drive around. And most of the technology around this is deep learning. So we don't have enough time to go into all the details on how deep learning works, but I do want to remind two principles that will help us through the demo. So the deep learning model is inspired by the way the human brain works. So basically, we have a multi-layer of neurons. Okay, the neurons get input from the outside world. There are different layers. Each layer does some processing, mathematical processing, passes the output to the next layer, and so on, until at the end we get the output, which is the probability of something to be something. Okay, what is this input means? The layout of the network is called the network topology, so it's important for us to understand that. The deep learning networks or topologies may differ by the number of layers, the number and the essence of the neurons, what the neurons are, the different connections, and there are some known topologies that are known to solve specific problems. Another concept that I want to go through is the two different steps in deep learning. The first steps, the main step in deep learning is the training process. So that's the process where we train the network. Basically, we provide lots of labeled data sets, so it's supervised learning. We then start the training process. We don't need, aside from providing a labeled data set, like in the example, it would be a lot of images, they're all labeled. We don't need to do anything else. We define the topology. We let the computer train itself. And then the output is a mathematical model of the topology, the neural network. After the training, we have the second step, which is the inference. Okay, this is taking a new data, new kind of data, completely new image that the computer never saw before, and then allowing it to know what the image describes. Okay, recognize that this is a person, and the results that we're getting with deep learning in these kind of problems are quite amazing. So our tool does provide the end-to-end solution. I will focus today mostly on the training part. So the problem with deep learning today is that it's still not that accessible. Okay, it's quite overwhelming. There are a lot of tools, a lot of frameworks. The installation is not that hard, and we want to bring deep learning for everyone. Okay, deep learning for all, or in other words, to democratize deep learning. And that's how we came up with a deep learning SDK, software development kit. But basically, this is a free set of tools, both for data scientists and software developers, that allow you to do the entire pipeline of deep learning, develop neural networks, train them, and also deploy them. And it provides an end-to-end solution from the moment you decide you want to install the deep learning solution and until the time you want to apply it as part of a service or a software on an edge device. So just before jumping into the demo, I want to share with you some concepts that we have or we had when we developed the tool. First, we wanted the tool to be very easy. Just like you plug and play an electrical device, it usually works. So we want to make this very easy. So we're not inventing any new framework. We're using frameworks that you already know, but setting them up today is more difficult. So we created an installer. I will show the installer today. You can use it from your computer, even if you want to install it on a server, okay, because you need the power and performance. So you can install it from a Windows machine, Linux, or Mac. And you can install it on a server or also on a Mac, okay? And the idea is to get eventually the framework, optimizations, and a lot of tools all together with a one click. The second principle is to get you the maximum performance. So basically the problem, or not the problem, the challenge with deep learning is training takes a lot of time. For inference, it doesn't take a lot of time, but time is critical. So what we've done is we've bundled some mathematical kernel libraries that Intel has. We are providing as part of the tool an optimized framework. So basically we took the open source frameworks, we're optimizing them to work on top, again, of the existing hardware. You can always buy an accelerator, but using this tool, you can use your own hardware to get better performance. In some workloads, you can get 10 or 20x better performance on the same hardware. We have also optimized the hyperparameters for the Intel architecture. So again, you get better performance with the same accuracy or improved accuracy just by using these parameters. The next principle is to provide you some productivity tools. I think, again, to make deep learning accessible, easy to use, we need to provide you some easy start. So it's not only about the installation, but it's also getting your first steps very easily, and that's what I will demo today. We have a wizard-like tool for running deep learning. We have visualizations that will save you time because you start the training and then you see maybe the accuracy is not as good. You don't need to wait the entire time of the training, which does take time. Usually this takes hours, days, and for some tasks it can even take more than a week. And the last part, the last principle is to accelerate the deployment. So again, there is a huge gap between creating a deep learning neural network and training it and doing it on the data center, and then eventually taking it to an edge device, to a mobile phone, to a headset camera, to a car. And different hardware platforms have different requirements, memory footprint requirements, power consumption requirements. And then maybe you have the best model with the best accuracy, but it will never fit your edge device. So we're providing a set of tools to compress, to quantize, and even translate the neural network from the topology that you wrote to the edge device requirements. So how can you consume the tool? Basically, as I said, we have the installer. So if you're an expert of deep learning, you can download the tool, you can use the installer to install the framework, and then work directly with the framework, and that's it. You get the performance, you get the ease of installation. But if you want more than that, we basically have two user interfaces. They're combined together. One is a step-by-step wizard, which again is very good if you want to start running deep learning. It has a lot of tooltips. It will guide you through the entire process, and we'll see that today. And the second is an interactive Jupyter notebook, which if the wizard provides you the ease of use, the Jupyter notebooks provide you the flexibility. So if the wizard has some limitations because we don't expose everything, because simplicity has its price, and you do want to take it to the next step and improve your accuracy by playing around with some parameters that we don't expose, you can use the interactive notebook. So I want to demo the tool, but I want to use a real-life use case that we did. So I'm going to share with you the process that we did as part of the development of a virtual reality helmet that Intel developed. It's called Project Alloy. Basically, it's a device you put on your head, and you control it using voice and hand gestures. As you see, no keyboard, no mouse. So you do need to control it somehow. So we will see the process behind creating the model that we did for analyzing the hand gestures. Okay, and so anyone can guess what the data set is? Data set is a bunch of pictures of hands, okay? So I'm going to do, the first step is to identify if an object is a hand or not a hand. So we'll do that first process. And then at the end of the process, I'll also show you a video of how successful that was. So basically, that's the data set. We will have a set of images that are tagged as images of hands, and a set of images that are tagged as non-hands. And let's jump into the demo. So before going into the tool and the deep learning process, I do want to show you the installer. I will not go through the entire installation process. But once you download our tool, basically you can get either on Windows or Mac, you get this kind of an installer, just like we install any application on your machine. But what it does, it will install, download the framework, all the optimizations for you. You need to set up a username and password to protect your data, because you can use the tool to install it on your machines, on premise, but also on the cloud. And either way, we're providing web interface, so we want to protect your data, so you provide the username and password for that. And then all you need to do is provide your server IP, if that's a Linux server. Okay? You need to provide your credentials if you want to use Amazon Cloud, or you can install it locally on a Mac. Okay? We don't support Windows yet. But that's it. Once you provide these details, and if you have a proxy or something, you have some more advanced settings, you choose HTTP or HTTPS, you click Next, and this will do everything for you. Okay? Even if it's a remote server, the idea is eventually we want to enable you to use the power of using a cluster, so we're also working on a distributed installation, but all from your machine. You don't need to log into Linux. You don't need to download code and compile code. You just do it using a simple installer. And after you install, then you can start using our web interface, or again, log in directly to the framework. But let me demo the web interface. So basically, this is how it starts, how it works. There are 3 steps for the training. As I said, we will not do the deployment today. The first part, you need to upload your data to the server. Okay, so we use our own data. The second is we create a data set from that set of images. And the last is to create a model. So we have a nice dashboard here to show you the last tasks. I don't have anything here just now. And I'll show you the upload process. So basically, again, to simplify, we have tooltips throughout the tool to explain you how to do it. Okay? You need to browse and upload a set of images that are compressed. Let's do the hands demo. in a zip or a RAR file, okay? So I'll do this. I'll pick this one. Give it a name. Click upload. This will upload and extract the images. Basically, I want to show you how it looks like. The RAR or the zip file, within it I have two folders. One is called hands, the other no hands. But you can do anything you want here, okay? You can use numbers, faces of people, pets, animals, whatever you want. Just put different categories. Each folder is a category. Within the category, within the folder, you have the images, the relevant images. You don't need to do anything aside from that. So we're uploading the images. Okay, once it's completed, it will move here. I'll use this example that I did before. And the next step is to create a data set. So as I said, we wanted to make this really simple. We created a wizard for all the different steps. So we'll give the data set a name. And then I need to select the folder, okay, to which I uploaded the images to. And now, as part of the deep learning process, I need to give the computer some validation data set. So you can either use the same images that you've uploaded and save some of the data for validation, which is used throughout the calculation of the network itself. An additional data set for testing, which can be done at the end. Okay, so the validation is affecting the deep learning process, the training process, and the testing is not. You can obviously use another folder. And here's another thing that we had in mind because we had a real problem. Sometimes the data that you have is not really balanced. This is a classical problem in machine learning. For images, this is a problem that is quite easily can be solved because you can augment the data based on your images. So we had a problem when identifying the hands. We had a problem that we didn't get the right accuracy because we didn't have the same amount of images for hands and non-hands. And we created this data augmentation feature, which actually improves the accuracy. So I'll not go through this. There are a lot of options here. But the idea with the tool is if you don't need it, you just don't use it. You just click next. This is a wizard. You click next, but this is a nice thing about it. Next is image processing. Okay, we might want to convert all the data to grayscale. Maybe we want to save it as color. We want to change the size or leave the size as is. If we want to resize, then there are different resize methods. These are all tasks that usually you'd need to either take different tools or use some Python scripts. Here you can do it within the tool. And then the last step is you need to take the images and create a data set, okay, or a database from them. So here we can select which data set and if we want to change the encoding of the image. And then click create and the process will start running. Okay, this is live demo. You can see here the amount of time that is left for the data set to be created. Okay, and this is something, again, you can, if it's a very long process, a huge data set, this process can take time. So you want to know the estimated time for finishing it. And here you can see that I have, again, two categories, the amount of images per category for the training data set, same for the validation and for the testing data set. So once we created the data set, we want to start the deep learning training process. Okay. So again, we have a section here for running the models. We'll go to this section. And here we also have a wizard that will guide us through the process. Today, the tool supports only Caffe framework, but we are working on adding TensorFlow. So in that case, the first step in the wizard will be choose the framework. And then you can use the same task to do different, to run it with different frameworks and compare your accuracy and your results. But here, we don't have the framework selection. We can choose the data. We need to choose the data set. Okay, so let's choose the one that we just created. Next, we need to choose the topology. If you remember, we talked about the deep learning topologies. So there are known topologies, okay, like LeNet, AlexNet, GoogleNet, which are, we call them state-of-the-art topologies. We know they're very good at solving image problems, depending on the image size, depending on the complexity. You can create your own custom topology, okay? But if you choose one of the selected topology, you can also run fine-tuning. Now, fine-tuning is a process that is much faster. You get a pre-trained model. Okay, we already trained the topology for you, so you get a baseline to start with. And if you choose to do fine-tuning, you should get good results because you have a baseline that was proved to be good. You can affect how aggressive you want the system to be with changing that baseline. So you can choose to change only the configuration of the last layer, or maybe change more the last layer. So there are different types of fine-tuning that you can do. Let's just do a simple training for this demo. And then you can do some additional data transformation. Maybe you want to have the mean image be calculated and then subtract it from all the images. These things can affect the accuracy. But if you want to just start running deep learning, again, you can use the defaults. And this is another interesting tab. This is the parameters, or what they're called hyperparameters, or you can call it the network configuration. These are parameters that definitely affect your accuracy and your runtime. We are choosing or recommending parameters based on the topology that you selected. So you get, again, better runtime and better accuracy. But these are things you definitely want to change if you don't get the right accuracy. Okay, how many epochs, which are sort of iterations of the deep learning, do you want to do? What is the batch size? How many images do I take each time? And what is the solver type? There are different solver types. These are basically traditional machine learning gradient descent, for example, algorithms that will help you choose the best model throughout the deep learning process. So it's an iterative process. Each time you get accuracy, you want to get improved accuracy. And then let's give it a name and start the training. So basically, I was talking a lot, but as you can see, the process itself is not that complicated. And we're starting the training process. Again, real time. You can see how much estimated time we have here. So this is going to take about 40 minutes. This specific configuration I chose, the specific data set I chose. But throughout the process, you can see, the losses getting lower. And you will, after the first epoch, you will see the accuracy going higher. So you can get some measurements on the accuracy on the training set, the validation data set, etc. during runtime. You can also see some analysis. I think it will not be available before the first epoch is completed. So let's choose this one. So you will see, for example, analysis on for the images that are labeled as hands, how many in the validation data set were actually identified as hands and how many not. Okay, obviously, deep learning is not accurate. It's not 100% accuracy. So you can see this. You can browse through the data set to see the specific images, okay, that were identified as a hand or not hand, or whatever data set you choose. Okay, it doesn't have to be classifier of two sets. And you can also select single images and classify them. So for example, I will take this image, ask it to classify. And by the way, you can do it during runtime. So you see this is 100% confidence that this is no hand. And again, not always you get the 100% confidence, of course. And not always it's accurate. Although this is a simple problem of a Boolean problem with two categories. So the next step that we will have here is also in the wizard, you will have the compression and deployment tools. So you will say, this is the target device that I want to choose to deploy it on, okay, based on a specific hardware architecture. And these are the limitations. And then we can offer you compression methods to get your model compressed. You will not get the same accuracy. But you can decide by yourself what is the compromise that you're willing to take with regards to accuracy. Okay, and as I said, this is the interactive wizard sort of tool and all the visualization that is supposed to save you time. But let's say you want to go deeper and you do want to do things more in depth and you're willing to change some more parameters than the ones that we exposed. So basically, you can switch to the advanced mode, which basically exposes Jupyter notebooks. Now, the nice thing about notebooks is that you can run actual code, but you also get a very nice documentation along with the code. So I'm going to demo today just the classification part. You can obviously do also the training. This is using PyCafe, okay, on top of Intel Cafe. So Intel Cafe is an optimized version of Cafe that runs faster. And don't be frightened with this. You don't have to use this section of the tool. You can run through the wizard. You can solve a lot of problems just using the wizard. But if you want the in-depth, you can switch to this mode. And then obviously we give you, how to set up the environment, how to load the library. I'll skip some of the steps here. Let's go directly to the demo of the classification. So here we can choose to load an image. Okay. And again, you can take this code and deploy it. So this is loading the image of, obviously, not a hand. Okay, and then running the classification. We will get a number, okay, of the class. Class is 1, so 1 is not a hand. And then if I will take a different image, and you can, within the tool, you can edit the code itself. You can create a notebook by yourself. You can write your own code here and then export it. So let me show you the image. So here is the image of a hand. And then I should get a different class, obviously. So here, this is a 0. So that's the sort of things you can do with interactive notebooks. You can obviously do the entire training process. But I wanted to show the classification. So this is the tool. I want to show you the end result that we got with the images. So we'll see a video. In the video, you'll see someone playing with the hands, and that's what the camera within the virtual helmet sees. Okay, that's what the camera sees, and it analyzes objects. Okay, if it's purple, it doesn't recognize it as a hand. If the object is green, it means that it was identified as a hand. Okay, so you will see it's not 100% accuracy. This is using the data set that I've showed you. Okay, in the same training process. So we have object detection here first. We need to detect different objects, and you see them in squares, and then you can see sometimes it identifies the hand as non-hand, sometimes it identifies the teddy bird as a hand. So it's not accurate, but it's quite good, and statistically it's good enough. So what you've seen is the first is the beta of the tool, and basically the tool is now in technical preview. You can go to the internet, download it, use it, and next week we are releasing the beta. So we did get feedback on usability to make things easier and more clear. So I do suggest to try out at least the beta, but we have a lot in the pipe. Okay, so just like you see, you have plug and train. Very easily you can run through the training process. We want to have the same thing for deployment, to add it also to the UI. So the data scientists, for example, can take the process end to end, or the software developers that is responsible for the deployment can do some training. We want to support additional hardware platforms. So Intel has a lot on its roadmap with regards to hardware for training and for inferencing. So we want to extend to these hardware platforms. And also, we're starting to add in TensorFlow as an additional framework. We have some additional tools for increased productivity, and not only for vision. So what you've seen is image classification for vision. Vision has additional problems like object detection, image segmentation, but we're also starting to work on solving text problems like document classification. So if image is not what you're interested into, you can still run deep learning with other problems. We have some more optimization coming in with the maximized performance, and especially the support of multi-node. So you can run through a cluster of machines, and these could be available in your organization anyway, so why not utilize them? And provide additional optimizations. And obviously accelerate deployment. So we have the deployment tool as a standalone. We want to integrate it to one tool. We support compression and we support quantization, but there are additional compression methods that we're working on to introduce. So this is what we have planned, and my key takeaway from you or request from you is basically to try deep learning. Okay, download the tool. It's not as frightening as it looks. You can download the tool. Again, you can give it a try right now, or you can wait for the beta that is going to be available next week. You can register and get notification. I have some cards here with the link. And if you even have specific problems that you want to work out with us, specific deep learning problems, we'll be happy to help and also learn from you on how to improve this. The idea is to have everyone be able to create magnificent things with deep learning. So thank you very much. And if anyone has any questions, then I'm here for that. Yes? Exactly. That's the point on this, is that you can get better performance using CPU. You can obviously go to the next step and buy an accelerator, either a GPU or a dedicated accelerator. But for most of the tasks, if you use the optimized framework, this should be good enough performance for you. So we do recommend to use servers, but the demo that I did is running here on this laptop. So it's definitely something, if you want to give it a try and you don't have huge amount of data, this is something that you can do. Any more questions? Okay, so you're welcome to pick a card, and if you have more questions, I'll be around to answer. Thank you very much.